We are in Denver, Colorado at the Optica Quantum 2.0 conference. And I'm here at the Menlo Systems booth with Daniel. Daniel, so far, you have had lots of discussions with many of the attendees. What are the main takeaways that you get from here?
I think that the main takeaway I've gotten is that a lot of these quantum companies kind of want to move from the lab to the professional space, and I think it's really exciting to see all of the desire for sort of a more professional approach to laser stabilization and to all of the different things a frequency comb can offer, which we are the frequency comb company, and I think that's a really exciting thing to see.
We are at a very high-tech, very scientific conference. When it came to frequency combs, what are the challenges that the people have been sharing with you?
Well, I think that the biggest challenge with the frequency comb is that historically people have viewed it as an expensive option, when really I think that the costs have come down and the needs have gone up. And so I think that we are really at the point where a frequency comb is the optimal solution for many of these atomic physics problems, where if you need to lock 8, 16 lasers, frequency comb is a very cost-effective and reliable, solid option to do for that.
You have something big to announce. We have a new supercontinuum line.
Yes.
What is the problem that supercontinuum line is solving for the quantum community?
Well, the supercontinuum line, basically, the problem historically has been if you want 8 lasers, you need to amplify comb light for through 8 different amplifiers, whereas the supercontinuum line uses 1 amplifier for 8 lasers. And it's also field upgradable. It's kind of a beautiful thing. And so a customer can say, hey, I have 2 lasers now, and I want to have 8 lasers in the future, and I don't know what they are. And we can field upgrade that in the future.
You also brought the dual comb laser, and that solves also many challenges.
Right.
What is the interest from this community in that dual comb laser?
So the dual comb lasers are typically more gas spectroscopy type experiments. So if you want to, look at methane or any of these gases, look at methane levels, there's a lot of groups that are really interested in doing that with dual comb lines. And I think that the other thing is that, right here we have our smart comb. And so this is our most compact frequency comb. And I think that we can use this to build a dual comb. We can use this as a frequency comb, and I think that's a really exciting space to be in because you can put it in a mobile platform of some kind.
We are today in Denver, Colorado. Next week, the whole photonic industry community goes to your home turf, goes to Munich, and you have some new facilities there. What are people going to be, when they come to see your facilities, what are they going to see?
I mean, they're going to see all of our production lines, how, basically all of these lines have been kind of turned from something that looked more like a lab to something that looks more like an assembly line. And I think they'll see, kind of how these different laser oscillators move from parts to a complete laser oscillator. And I think that's a really exciting thing to see, which is to see the whole process blossom.
Fantastic. Daniel, thank you very much. Thank you for coming to Optica Quantum 2.0.
Glad to be here.